An object of 3 kilograms is on the roof of a 16-meter building. If we let it fall freely, at what speed will it hit the ground, neglecting air friction? First of all, we need to express the data in SI units. A frame of reference can be described by a Cartesian coordinate system, and it is very important because the positions depend on the reference frame. Mass equals 3 kilograms. Initial height equals 16 meters. Try to fill in the gap. Initial speed equals 0 meters per second. Initial speed is equal to 0 because the object falls freely. We need to calculate the final speed. Try to fill in the gap. In this case, final height is 0. Read the following text and try to fill in the gap. Since we neglect friction force, we may apply the principle of conservation of mechanical energy. Try to fill in the gap. The mechanical energy of the object at position 1 is equal to the mechanical energy at position 2. Secondly, we need to express the formula we are going to use. We must take into account that mechanical energy is equal to kinetic energy plus potential energy. There is no kinetic energy at position 1 and no potential energy at position 2. Try to fill in the gap. We must use the formula for kinetic energy. Try to fill in the gap. We must use the formula for potential energy. Try to fill in the gap. Thirdly, we substitute the data into the equation and solve. Try to fill in the gap. Acceleration of gravity g equals 9.8 meters per second squared. we can cancel the number 3. To find the value of the unknown, we must solve the square root. Try to fill in the gap. Try to fill in the gap. The solution, rounded to 2 decimal places, is 17.71 meters per second. This is the end.